Hello students, today our topic in mathematics is to find the surface areas and volumes of solid figures like cuboid and cube. Until now, we used to find the area of plane figures having only length and breadth. They were called plane figures. Plane figures can be drawn on sheet of paper or on blackboard. Now, we will study about solid figures. They are of 3 dimensions like length, breadth and height. In fact, in our daily life, we come across many objects of similar shapes like a wooden box, a tea packet, a matchbox. These objects have similar shapes and such objects can be called cuboid or cubes. Let's have a look on a cuboid. A cuboid is in fact the arrangement of 6 rectangular figures having length, breadth and height. This is the length of the cuboid, this is the breadth of the cuboid and this is the height of the cuboid. In fact, the cuboid is the arrangement of 6 rectangular surfaces. Take a look on this box. This box is of a cuboid shape. It has 6 surfaces. You can count yourself 1, 2, 3, 4, 5 and 6 surfaces. And all these surfaces you can see are of rectangular shape. Now, if these 6 rectangular surfaces are arranged in like a box shape, the figure so obtained is called a cuboid. Now, how can we find the surface area of the cuboid? By surface area, we mean total surface area of the cuboid. That means we have to add all the 6 surfaces, the area of the surfaces of these 6 rectangles. Now, how can we find the total surface area of a cuboid? Take a look. If we look at this box, we will have 6 rectangles. One is the height and another is the length. So, the area of that rectangle will be length into height. And at the back of this box, there is another rectangle of the similar lengths with length and this breadth denoted as height. So, in this rectangle, this cuboid, we have 2 surfaces with rectangular surfaces having dimensions length and breadth. We have 2 surfaces with having dimensions height and breadth, and we have 2 surfaces with dimensions length and height. These are 2 rectangles opposite to each other, have same dimensions, like this rectangle, and opposite to that rectangle is this one. They have same dimensions. The rectangle on that side and opposite to it has the same dimensions, and this rectangle and opposite to this has same dimensions. So, the total the area of these two rectangles is twice length breadth, twice height breadth and twice length breadth. If we take 2 as common, it will give length breadth, breadth height and height length. And the total surface area of the cuboid is twice length plus breadth plus length, twice length into breadth plus breadth into height plus height into length. Now, if we take only the 4 sides of the cuboid and ignore their bases, if we ignore, suppose this is the rectangular box, we ignore the top of the rectangular box and its base, we are left with 4 side rectangles that we call the lateral surface area of the cuboid. You can call it the area of the 4 walls as well. Now, we know the top and the bottom of the cuboid has dimensions length and breadth. We can erase length and breadth from this hole. and the area of the 4 side walls or the lateral surface area of the cuboid will be as the lateral surface area of cuboid will be twice breadth height plus twice height length. And if you take twice height as common, in brackets you can write it as length plus breadth. So this gives the lateral surface area of the cuboid. It is equal to twice height into the sum of its length and breadth. Note that in cuboid, the lateral surface area is only having its 4 side rectangles. The sum of the 4 side rectangles is the lateral surface area of the cuboid, or even you can say it, the area of 4 walls of the cuboid. So these are the total surface area of cuboid, 2 times length breadth plus breadth height plus height length, and the lateral surface area of cuboid, or you can say area of 4 walls of cuboid. 4 walls of cuboid is twice height into the sum of its length and breadth. Okay? Then we come to volume. The volume of cuboid is equal to the product of its length, breadth and height. Now, when the question is framed, you have to guess and imagine what sort of cuboid and what dimensions and faces are given in the cuboid. Now, if we take any cuboid and we take 2 such surfaces which have a common line. Suppose in this cuboid, we take this as one surface and this as second surface. Now, between these 2 surfaces, we have a common line segment. We call it as edge. So, instead of saying sides, we can say edges of the cuboid. So, what is the edge of the cuboid? A common line segment between any 2 consecutive or adjacent surfaces of a cuboid. Now, there is another point where the 3 surfaces of the cuboid meet. This is the common point of the 3 adjacent surfaces of a cuboid. This point is called the vertex of the cuboid. So, the side of the cuboid can be called as edge of the cuboid, and the corner of the cuboid can be called as vertex of the cuboid. Right? Now, we will know about the diagonal of a cuboid. A simple classroom or any room having its definite length, breadth and height is a good example of a cuboid. Now, what is the diagonal of a cuboid? It is an imaginary line which you draw from one corner of this cuboid to its opposite end at the bottom of the another vertex. The top vertex and the bottom vertex of the opposite side. The line segment so joined is called the diagonal of a cuboid. The diagonal of a cuboid is denoted by D. It is like this. The diagonal of a cuboid can be denoted by D and is equal to the square root of its square of length plus breadth square plus height square. So, we can have examples to understand more about the surface areas, the total surface area and the lateral surface area of the cuboid. Now come to the cube. As we know, cuboid is a solid figure. It is in fact a 3-dimensional figure with varied length, breadth and height. Now what is a cube? Simply, a cube is again a cuboid, but in that case we have 6 surfaces that are square in nature. these are having square sides. Again, this cuboid is called a cube. Instead of writing length, breadth and height, we say the edge of the cube from all its sides is same, and the total surface area of a cube is, because the area of the square, suppose we take the example of a cube, this is a good example of a cube. You can see one of its faces is of a square shape, and the area of the square is side into side, that is side square. If we keep the edge of the square as L, then the area of one of its faces will be L square, side into side. L into L is L square. And how many surfaces does a cube have? We count that. 1, 2, 3, 4, 5, and 6. So you multiply L square by 6 and you will get the total surface area of the cube. It's 6 edge square. The product of the square of the edge with 6, because the cube has 6 square surfaces. It can be solid, it can be hollow, but the surface area remains the same. Even the volume remains the same. Even if a cube or cuboid is hollow, the air contained in it is its volume. So it does not affect the volume or the surface area of the cube or cuboid. Come to the lateral surface area of the cuboid. Again, for the lateral surface area of the cuboid, we have to subtract two areas of two surfaces. Any face of a cuboid or cube is the base of a cube or cuboid. Now, if you subtract two surfaces from the total surface area, you will get the lateral surface area of the cube. And the lateral surface area of the cube is equal to lateral surface area of cube is equal to, now from 6 squares we subtract area of 2 squares. That means only 4 squares are left. So the lateral surface area of cube, or the area of 4 walls of a cube, is 4L square. Again, L is the edge of the cube. Now come to the volume of cube. Volume of cube is equal to length, breadth and height. Because length, breadth and height are same, we can write it as L raised to power 3. That is the volume of the cube. So if we sum up with cube and cuboid, the total surface area or the surface area of a cuboid is twice length breadth plus breadth height plus height length. And the lateral surface area of cuboid is twice height into length plus breadth. Volume of a cuboid is length into breadth into height. Now come to the cube. The total surface area of the cube is 6 into edge square. The lateral surface area or area of 4 walls of cube is 4L square. And the volume of a cube is the cube of its edge, the product of 3 times the product of its edge. And come to the diagonal of a cuboid. Diagonal of a cube. The diagonal of a cube D is equal to, this is L square, and the breadth is also in cube is written as L, again L square, and H is again L square. For a cube, length, breadth and height are all equal. Understand this, the diagonal of cuboid can be replaced with 3 L's and it becomes root of 3L square. Root of 3L square, root 3 as it is, and square of root for L will be cancelled. So the length of the diagonal of a cube is equal to square root of 3 into L. L is the edge of the cube. Now to understand all this, let us take some examples from the book. Now we take an example from a book. It is given that there is a plastic box 1.5 meter long, 1.25 meter wide, and 65 centimeter deep. This is a plastic box where its length of plastic box is 1.5 meter. And width or breadth means the same thing. Width of plastic box can be denoted by B is 1.25 meters. And it is deep, 65 centimeter. Deep means depth, or height means the same thing. You can write depth of plastic box and you can denote it by letter H. This is 65 centimeter. Now, this is purely an example of a cuboid. To understand this, let us draw a cuboidal figure. First, draw a rectangular shaped two-dimensional rectangular figure, then another rectangular figure, and join the corners. You will get a cuboid. And take this an example of a plastic box with a length of 1.5 meters, with a breadth of 1.25 meters, and with a height of 65 centimeters. This is the plastic box. It is given it is opened at the top. Now, the plastic box is of a cuboidal shape because length, breadth, and height varies, and one of its surfaces is open. That means how many surfaces we have to take into account? 1, 2, 3, 4, and 5. So, a plastic box is given with one of its top open, and we now need to consider only 5 surfaces. What is the question further saying is that ignoring the thickness of the plastic, determine the area of the sheet required for making the box. Now, for making the box, we need to take into account only 5 surfaces. And one thing you need to understand is that the units for length and breadth is same in meters, while as the height or depth of the plastic box is in centimeters. So, to calculate the area, it is very necessary for us to keep all the units uniform. Either you can change meters into centimeters or centimeters into meters. There is nothing wrong with that. But if you look at the second part of the question, you will see that the cost of sheet for it, if a sheet measuring 1 meter square costs rupees 20, that means the cost of the sheet has been given in meter square. So, it is necessary for us that the units for this should remain in meters rather than centimeters. Although, if the cost of the sheet had not been given in meters, we would have changed this all into centimeter. Nothing wrong with that. So, to change centimeter into meter, we divide it by 100 because 100 centimeter is equal to 1 meter. And you see 65 centimeters gets changed into meters when we divide it by 100. If you take it into decimal form, it will be 0.65 meter. Now, what will be the area of the plastic sheet needed? Again, the top of the plastic sheet is open, only 5 surfaces are to be considered. So, we write area of plastic sheet. We have 2 ways to solve that question. Either we subtract one base because the top and the bottom base of a cuboid is having dimensions length and breadth. We can either subtract the area of length and breadth one base with the 6 bases, or we can add one base to the lateral surface area of the cuboid. 6 minus 1 is 5 and 4 plus 1 is 5. Same thing and nothing wrong with that. So, area of plastic sheet is lateral surface area of cuboid plus area of one of its bottom base. So, lateral surface area of cuboid is twice height, length plus breadth, and area of bottom base is length into breadth. So, put the numericals in the definite value areas. 2 into 0.65 and length is 1.5, breadth is 1.25 plus length into breadth 1.5 into 1.25. So how much is this? 2, 5, 10, 2, 6, 12 and 1, 13. So this is 1.3 into 2.75 plus, now 1.5 into 1.25. How much is this? Multiply 15 by 125. One 875, 2 and 1 3. Put decimal 3 digits away from the back, it becomes 1.875. So when you add up, you will get the total surface area of the plastic box. How much is that? 1.3 into 2.75. It is 5753 and 3.575. Which is equal to 1.875, 3.575 plus 1.875. And how much is this? We add there. It is 5.45 meters square. So, the area of the plastic box is 5.45 meters square. Now, we need to find out the cost of the plastic for making such type of plastic box. Now, what is the cost for per meter square of that plastic material? It is rupees 20. It is rupees 20. Write down. Cost of 1 meter square of plastic is rupees 20. How many meters square of plastic does this plastic box has? 5.45 meters square. So cost of 5.45 meters square of plastic will be 20 into 5.45. Simply multiply it by 2. 510, 2489, 2510, and place 0 at the end. After that, place 2 decimals from behind, you will get 109. So for making that plastic box, the cost will be rupees 109. One thing in that question, again, I am repeating that the units should be uniform. If the units are in centimeters, put all the units in centimeters, or if it is in meters, put all them into meters. And first of all, one should read the question thoroughly, because in the second part of this question, it is mentioned cost of plastic box in meters. So we necessarily need to change the units in meters. Another question is the length, breadth and height of a room are 5 meter, 4 meter and 3 meter respectively. Find the cost of whitewashing the walls of room and ceiling at the rate of rupees 7.50 per meter square. Again, this room is of cuboidal shape and only 5 surfaces are to be taken into account. The whitewash is only for the 4 walls and the ceiling. That means the bottom of the room, that is of having dimensions length and breadth, are to be subtracted from the whole area. And it is exactly the same question that we previously did. Okay? Now, three cubes of side 5 centimeter are joined end to end. Find the surface area of the resulting cuboid. Now, the question is simple. Suppose we take any 2 cubes. For example, I have these 2 chalk boxes. Suppose they are both in cube shape and we join them end to end. What will it become? Yes, definitely it becomes a cuboid. Only the length of the cuboid will get varied. The breadth and the height remains the same. Same is case with this question. If we take these 3 cubes and join them side by side, let's draw these 3 cubes. 1, 2, and 3. Okay? So, if you add these 3 cubes, you will get a cuboid. Only its length, 5 centimeter cube, 5 centimeter cube, and 5 centimeter cube, forms a cuboid, and the length of that cuboid will be 15 centimeter. So, whenever you join 2 or more than 2 cubes side by side, you get a cuboid. And what gets varied? Only the length. The breadth and height remains the same. Now it is very easy for you to solve that question. So, the resulting length of resulting cuboid is 5 plus 5 plus 5. That is 15 centimeter. Breadth remains the same. There is no effect on the breadth and height. So breadth of cuboid remains 5 centimeter and the height of the cuboid is again 5 centimeter. So surface area of cuboid. By surface area, we mean total surface area. Whenever you have to find out the lateral surface area, it is mentioned there, find the lateral surface area or area of four walls of the cuboid or cube. So surface area of cuboid means total surface area of cuboid. In short terms, we can write it as TSA is 2 times length breadth, breadth height and height length. 2 times length is 15, breadth is 5, breadth is 5, height is 5, height is 5, length is also 5. Sorry, length is 15. So 15 into 5 is 75, 5 into 5 is 25, 5 into 15 is 75. So if you add up this, you will get 2 into 75 plus 25 is 100 and plus 75 is 175. So 175 into 2 is 350. So the total surface area of the resulting cuboid is 350 centimeters square. There is another tactical question, that is the question 3 from exercise 13.1. It is given the floor of a rectangular hall. I will write this for you. The floor of a rectangular hall has a perimeter 250 meters. If the cost of painting the 4 walls at the rate of rupees 10 per meter square, rupees 15,000. Find the height of the wall. Find the height of the hall. Now this is another tactical question. The floor of a rectangular cuboid. Now we know a cuboid is of 4 rectangular shape. Now if we take this as a room, then this will be its floor. The dimensions of the floor are length and breadth, and the perimeter is the sum of all the sides of that rectangle. Now perimeter of a rectangle is twice length plus breadth. How can we solve that? Now, perimeter of rectangle is a 2-dimensional figure with only length and breadth, and perimeter of a rectangle is the sum of its length and breadth multiplied by 2. So it is given by 2 times length plus breadth, that is the perimeter of the rectangular hall. This is 250 meters. Keep is as equation 1. Now another part of that question is given, that the cost of painting the 4 walls of that hall. The 4 walls of that hall covers the lateral surface area of the cuboid, and the cost of painting for the walls is rupees 15,000 at the cost of rupees 10 meters square. So this can give us the lateral surface area of the hall. Lateral surface area of hall is equal to total cost that went into the painting of the hall divided by the cost of painting per meter square, that is rupees 10. If you divide this by, you will get the area of 4 walls of the hall. This is 1500 meters square. If we go by the formula of the area of 4 walls or lateral surface area of the 4 walls of cuboid, it is given as what? Lateral surface area of cuboid, because hall is of the cuboidal shape, is 2 times height into length plus breadth. So 2 times height into length plus breadth is the area of 4 walls of the cuboid, and this is equal to 1500 meters square. We can equate them. We can equate them. Now on equating them, you will have twice, even you can write twice length plus breadth into height. Nothing wrong with that. Twice height into length plus breadth, or twice length plus breadth into height is same, and this is equal to 1500. Now what is twice length plus breadth equal to? Twice length plus breadth is equal to 250. Instead of twice length plus breadth, you can write 250 into h is equal to 1500. No need to put sign between 250 and h. It means product form. And when you transpose it, it gets into division. 250, 1500 divided by 250 is 6. So the height of the hall is 6 meters. And this is the question done for you. Right? Let's take another example of cube and cuboid. A cuboid has total surface area of 40 meters square, and its lateral surface area is 26 meters square. Find area of its base. Now, this is another tactical question where total surface area and curves or lateral surface area has both been given to find the base of that cuboid. Again, we will go through the formulas. Now, total surface area of cuboid is 40 meters square, and lateral surface area, LSA, of that cuboid is 26 meters square. Now, if we go through this, lateral surface area is contained in total surface area. So, if we write total surface area of a cuboid, it is 2 times length breadth plus breadth height plus height length. Now, if we will disintegrate it, this is 2 times length breadth plus 2 times height is to be taken as common, length plus breadth. Now, you see the total surface area of cuboid. The total surface area of cuboid is the product of the area of its 2 bases and the sum of its lateral surface area. So, total surface area of cuboid is 40 meters square into the product of 2 bases, and this is the lateral surface area of a cuboid. Total surface area of cuboid 40 and lateral surface area of cuboid is 26. Transpose 26 to the left, and subtract it with 40. What do you get? 14 is equal to length into breadth, and length into breadth is the area of the base. It becomes 7. So the area of base of that cuboid is 7 meters. There is another question for cuboid where we have given the diagonal of a cuboid and the dimensions of the cuboid. How can we relate the relation between the diagonal of cuboid and its surface area? A very good question. Let me read this for you. The sum of length, breadth and height of cuboid is 19 centimeter and length of its diagonal is 11 centimeter. Find the surface area of cuboid. By surface area, we mean total surface area of cuboid. That is to be ascertained. So, first of all, write the information what has been given. Sum of length, breadth and height. Let length be denoted by L, breadth be denoted by B and height denoted by H. And the sum of length, breadth and height of cuboid is 19 centimeters. And the length of its diagonal is 11 centimeter. Recall, what is the formula for the diagonal of a cuboid? It is D is equal to root of L square plus B square plus H square. This is the formula for the diagonal of a cuboid. It is square root of the square and the sum of the length, breadth and height of a cuboid. The diagonal is 11 centimeters and the square root of L square plus B square plus H square. Take it as equation 1 and squaring equation 1, squaring both sides. We get 11 square is equal to root of L square plus B square plus H square whole square. Cancel square and the root, you get 11 square is 121. L square plus B square plus H square is equal to 121. Keep it as equation 2 and put this in a box so as this is highlighted. Now again, the length, breadth and height of a cuboid is equal to 19 centimeter. Length, breadth, height of a cuboid is 19 centimeter. Squaring this, squaring both sides. It's length plus breadth plus height whole square equal to 19 square. What is 19 into 19? Find out. It is 361. So, again, if we go into the unit of polynomials, we will find that there is an identity in algebraic expression a plus b plus c whole square. And what is a plus b plus c whole square equal to? It is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Use that identity in length plus breadth plus height whole square. You get length square, a square, breadth square, height square, plus twice length breadth, AB, BC, CA. And this all is equal to 361. That is 19 square. What is length square plus breadth square plus height square equal to? Refer to equation 2. It is equal to 121. So write down 121 there and repeat all this. Length, breadth, height, height, length is equal to 361. Twice length, breadth, height, height, length is equal to 361 minus 121. How much is this? 240. So, what is, again, recall, what is twice breadth, length, breadth plus breadth, height into height plus height, length? It is the total surface area of a cuboid. Therefore, the total surface area of cuboid is 240 meters square. I hope you have understood this today.